Okay, this is for graphing parabolas from section 7.07. So the question says, which is the graph of the parabola with the equation y plus 3 equals 1/2 times the quantity x plus 1 squared? All right, well over here on the right are some general equations for parabolas. Um, since this equation starts with a y, we know that it's going to have a vertical axis of symmetry, which just means that the line where your parabola is symmetric is vertical. And so that's one reason this graph, you know, would match with that. It does have a vertical line of symmetry right down here through these points. And then what you're going to do is you're going to try to find out HKA. Those are the three things that you really want to be able to narrow down which parabola this one fits with. So the value here is k, and notice that it's y minus k. So if I wrote this with a minus sign, it would really be y minus -3. So my k value is really -3. So basically just remember it is the opposite of the sign right here. And then the same thing with h. Your h value, it has a minus sign here, so if I rewrote this with a minus sign, it'd be x minus -1. So in other words, my h value is -1. Again, just the opposite of that sign right there. So my center point, if you notice, it's h and then k. So it's -1 comma -3. So let's double check, is this point? Yes, my vertex is at -1, -3. So that checks. Our center point looks good. Now, the second thing you want to do is find the focus. What you want to do is you actually want to find your A value and then use this formula to find your focus, F. The focus is the distance between your vertex and your focus point. So let's just find the distance. What is the distance between these 2 points? They're kind of real close together there, but if we look at because that's a vertical distance, we want to just look at the Y value and we say, what's the difference between -2.5 and -3? So that right there is a distance of 1/2. Okay, so that's what we're hoping, that if this is the correct graph, that my focal length will be 1/2. Now you might be saying, oh yeah, it's 1/2 right there. Well, that is not your focal length. That's not F. So F, what we have to do is we have to use this formula. What is right there is actually A. So this is my A value, and it might still, you know, A and F could be the same, but I don't want to assume that it is. I want to take this 1 over 4A, and I want to plug in my A, and I want to solve for F and just double check. So I'm going to have 4 times 1/2. Well, 4 times 1/2 is really just 2, because half of 4 is 2, and so that does end up being 1/2. So my focal distance is 1/2, which matches with this, so this would be the correct graph there. Okay, let's take a look at another one. Alright, so it says, what is the focal length of the parabola with this equation? Okay, so we're just looking for focal length this time. Well, if I, oops, didn't mean to write there, sorry. Oh, now it's gonna, okay, well, we don't need that equation anyway because this is another vertical one because it starts with a y. So we're going to concentrate on this equation. I do have y minus k, so I have y minus 4. And then I have, on this side, I want to look at it in this form, a times x minus h squared. So it looks a little different here, but if I rewrite it like this, since x squared is really the same as x minus 0 squared, because if I did x minus 0, I would get x, and then squaring that would give me that x squared. So I wrote the right side just to look like this equation so that we can easily pick out a. So a is just that value in front of the parentheses there, and so that's my a value. I want to find the focal length, which is F. So F is equal to 1 over 4 times A. Well, my A value is 3/8, so I want to do 3/8 times 4 over 1. I'm going to do, that's my denominator. It's an ugly fraction right now, but we'll work on simplifying it down. One thing I can do is cross cancel. So 4 goes into 4 once and 4 goes into 8 twice. And so that would actually be 3/2 down there. Then you have two fractions that you are dividing. So remember the rule is copy dot flip. So the top fraction is really 1 over 1. So I'm going to copy that. I'm going to flip the bottom one over. And then multiplying that would give me 2/3. So that is my final answer for my focus. And that does match with option A there. Okay, last question. This one says the equation of a parabola is x equals -4 times the quantity y minus 1 squared. What is the equation of the directrix? All right, let's look over here for a minute. If you have a parabola, a horizontal parabola which opens to the right, or it could also open to the left, which is what we have here because it's x equals. So anytime you have x equals something, it's a horizontal one. There's also a very similar thing for vertical, except the y and the x are switched in the equation, and it opens up and down. But a directrix is really just a line, and the distance between from the vertex to the focus and the vertex to the directrix are always the same. So remember in the other two problems we found f. We found this f value here. And so what we're going to do in this problem is find that same f value. So to get to that, we need a, and a is always this number right here in front of the parentheses on the right side. And so we're going to use the formula. We're going to plug in a. So we're going to get 1 over 4 times -4, which would be -1/16. 4 times -4 is -16, but we usually write the negative in the numerator. So I also copied this here because this is important. It says if f is positive, then the focus is to the right of the vertex. Okay, well ours is not positive, ours is negative. So it is to the left or below the vertex. And this in below would be if it's a vertical parabola. In this case it's horizontal, so it's left of. So this is a picture of where the focus would be positive. You have the vertex and the focus is to the right of that. Our picture is different. Our vertex is here, but our focus is to the left. So the directrix line is actually here. Oh, and that would actually probably be, sorry, drawn the other way. So that's, the picture of what is going on there. But what you're really finding when you find the directrix is you're just finding the equation of this line. So remember, if you have a vertical line, that it's x equals whatever this constant value is here. So really what we want to know is what is this value? So if our focus is at -1/16, remember that your directrix is just the same distance, but in this case it's going to be to the right. So if your focus is at -1/16, then your directrix is the same distance but just in the opposite direction. So it's going to be over here 1/16 positive. And so that's going to be the equation of the line right there, because that's the value right there. And so so that's it. That's how you get that equation there. And I guess I should also add something else. The reason that you know that it's, if the focus is -1/16, that this is going to be +1/16. It would be different if you if this was not sitting at the point at an x value of 0, but it is, because if you look at your equation, this is x minus 0, y minus -1, so your center point is at 0, 1. So we could kind of redraw this, might help. So we have 0, 1, so let's say this is your y-axis. 0, 1 would be there. So your parabola is going this direction, and the focus is at -1/16. So because this is the origin, 0, 0, -1/16 would be, it's probably not quite to scale, but over just a little bit that direction. So your focus is going to be here, your focus point, and then your directrix will be that same distance but on the other side. And that's just a line there. And so that's why, again, it's x equals positive 1/16. If your center point was at something else, like if it was at 1, 1, you would have to take that x value and add the 1/16 to it to, figure out what your equation for your directrix would be. I hope that helps. Let me know if you have questions.